you were sending some emails on the radiation numbers. We should talk about those.
Yes, good idea.
This is the document, and this is part 2. I've been looking for part 1. It was part 1 where those other images that we put on the Alice site came from. But you see what they've done? They've copied these out instead of photographs, just garbage images. It's almost like they're redacted in a certain way. But this is the module that they put up. It's not actually on the ISS. This was launched from the space shuttle, and they even have pictures of it loading into the space shuttle. It shows here, like, they put this up for 5.8 years in low Earth orbit.
Okay.
That's it being unloaded. That's the Canada Space Arm unloading it. This particular module is not on the ISS.
Right, okay.
But they're showing it here. But here's polymer film. Here's before, and you see all the panels there, and here's after. They're completely gone. Just amazing. And I mean, they come down and they're talking about atomic oxygen just on the thermal control blankets and everything else that they had on board the thing, and the damage they're doing. They're being delaminated and the whole 9 yards all the way through this document. Just page after page. And then they're showing here after they scan it, the damage that's being done.
So are they looking purely for the radiation damage?
They're looking for the exposure from VUV radiation, atomic oxygen reactions, and of course the vacuum of space. When you come down through here, they show where they're located on this thing, the trays. Here's an image of them loading it on Columbia. They're loading this on, getting ready to put it on there. There's their payload on the thing. These guys aren't in spacesuits, they're just in clean suits. But this document is the one that has been deleted that you can't buy, and I just happened to come across it.
Really?
And I want to find part 1. This is part 2. And part 1 is the one that I took that image from. And then you see this. This is that intrusion, so-called, into the thing. And this is the one that came off of an album cover. That's not from the ISS. But they have all the graphs and charts, everything in here on the degradation. It could be somewhat modified, but I'll tell you, when they get into the Captain film, that beautiful adhesive tape that they were talking about that worked up to -6 or whatever. Now, if they only developed an adhesive, I'll come down to it here. There's the Captain film there. This is what's happening to it.
Wow.
And that's a stronger film than the other polymers out there. And here's polyester, completely damaged.
Because polyester is what backs the film they're supposed to be taking.
Yeah, and here's a before and after on the tray. See, there's the damage. There's these things completely damaged here in this shot. This is the one from space. There's the pucks. These are the same one. In the original document, these were full color images. There's another image.
Yeah, that's it. Considerable damage being done there.
And this particular document, of course, is describing why that happens. There's another shot of the vehicle, which end is pointing towards the Earth, and you name it. And then all these graphs that are included. Like I said, it's over 500 pages with multiple types of plastics and everything else. That's the control, and that's after.
Oh, good God.
FEP copolymer exposed in here. So you see they've been using every different kind of material they can think of to put on board these things, and you're seeing damage to everything.
Well, it's fair that they've done it. It's a good system to have carried out, because at least they know what the damage is going to be. What's that say there?
Well, this is Captain Dielectric bonded with an epoxy fiberglass.
All right, yeah, okay.
And you can see it delaminating. Like I said, they took the color away. And this is polyamide film. You can see the damage to that.
Yeah, it is.
And this is 3 millimeters of polyamide film damaged. And this is an impact crater that happened on one of the stuff. So like they are getting hit with stuff out there. They don't ever put that through.
No, they don't.
This is on the pearl scent outgassing deposits on the Captain polymer. You can see it's all breaking apart right through there.
Yeah, it is. God. It's quite heavy damage there.
Just incredible. This is nicotine satin. They went through an awful lot of stuff here. There's another shot of those images where these are just completely gone.
Yeah, there's ones on the left.
The pucks are empty.
Yeah.
The material's completely gone. And this is a close-up.
My God. Yeah.
They've done an awful lot of testing. And then, of course, they have all the graphs and charts. This is aluminized, Captain. I mean, they're trying out new products all the time, but look at the damage. Destroyed.
Yeah, look at it. I mean, it's relatively small, but...
This is the type of damage that's being shown in here. When it breaks through the outer layer, the atomic oxygen is creating little pinhole defects in it. This is aluminized, Captain, and it's just breaking it all apart, and it just breaks down.
Yeah, it is.
And here it's showing more detailed. It's showing how the atomic oxygen. Now, when we manufacture products, that atomic oxygen is trapped within man-made materials. And they might have to start making these materials in a vacuum to stop this from happening.
Yeah, because that's quite heavily damaged there, isn't it?
Well, yeah, it's escaping the material. It's destroying it as it's doing it.
So anything manufactured on Earth will include oxygen, and that oxygen will in turn be outgassed.
That's in glass, that's in aluminum, stainless steel, titanium.
Anything manufactured under Earth conditions.
And it's showing you how the damage is being created when it's pushed in this. And this is showing you the actual force of a vacuum. This material wants to escape, and that's a lot of force that it's creating to do it. But everything, you can hardly see in these images. I mean, if they were nice color images.
It's almost like they're trying to remove the information.
Oh, here's a silicone-coated bicycle reflector. Here's the shot of it with an electron photograph of it. This is a silicon-coated bicycle reflector after a significant atomic oxygen attack. So it's a nice little piece of plastic that you mold, and then here's just a higher resolution of that. But to say materials aren't damaged, like they're showing everything here is damaged, and these samples here. They're showing that the darker they are, the more damage there is to them.
Well, it's the radiation and the vacuum combined would attack anything manufactured here on Earth. You say atomic oxygen will be the first thing, or one of the first things to be removed from the material.
Yeah. Well, like I said, all of the stuff in this document, like if these were nice clear color photographs, if I could find the part one of this, because that's the part that was done basically at the Sandusky chamber, but you see everything is damaged. It doesn't matter what they're testing here. They're not showing no change in the material from anything they've tested. This is Teflon here.
And that's damaged too? Good God.
Yeah. So even if they wanted to stop cold welding and they're coating it, it's still going to weld itself together because it's going to eat this away. They're coating it with ceramics, they're coating it with everything.
Yeah. So Teflon doesn't protect.
No. Every one of these.
Exposed Teflon. Right. Okay.
And again with the Teflon. Look at the damage there. That's just incredible. Look at the way it just pimples the thing.
Well, it weakens it.
Well, it's breaking down the entire structure for the atomic oxygen reacting to the vacuum, right? And of course, here's all of the charts. These things are off-gassing as well. Fluorine, carbon, silicone.
There's an interesting parallel here. I was watching a film the other night on the ancient Egyptian vases, which are manufactured to incredible tolerances. And they've now subjected them to a scanning electron microscope. And it's showing some interesting metallic components in those vases, parts of which recovered from Saqqara in Egypt, south of Giza. So it's interesting that the same thing is applying here. They're using scanning electron microscopes to look at the information that would be available.
When they're doing those vases, they're gathering the clay, of course, from certain, or are they actually made from stone?
Yeah, made from granite or schist, or
not like they're baking clay and making a vase.
Yeah, it's
right?
not.
You could get all kinds of impurities in the mix when you're doing that. But of course, when the rock is volcanic, it's going to have an entire mixture of materials in there as well.
I know. It's absolutely extraordinary. I mean, granite is a very strong material, but it's very brittle. It'll break most of the time. It's quite extraordinary, the information that's coming out now.
They would have to use something more on the lines of a laser or something to remove the material.
It's something like that that appears to be happening. There's one, I think it was posted a couple of days ago, when he found somebody who volunteered his electron microscope to look at these and interpreted what he was seeing. It was absolutely extraordinary. I mean, it's about 2 hours long. You think, looking at that, you've got to be mad to watch 2 hours of electron microscope images, but it's what's being discussed. It's quite extraordinary.
The one thing I was going to say about the space program, I'm sure they're trying. They're really trying to do something, but it is so slow. We just looked at the materials. That's a hell of a lot of work. Over 15 years they were working on that, testing every damn material out there. And the stuff is not viable for any long-term thing in space, even for satellites. What are you going to build a satellite out of? It's going to break down out there. You're better off with old rocks that are already broken down. They last out there because you got the moon and everything else, asteroids. You need to build them out of that stuff that were created in a vacuum that don't have the effects of atomic oxygen. They're already broken down. They're already surviving in minus 250 degrees. So everything we do is very, very slow, and it's boring. Okay, what we do to a lot of people is boring because the truth is boring. So right from the early 60s, you didn't have just a space race underway. You had to excite the population. You had to keep them interested. You need to invest not only financially, which returned back to the population. It made the country very healthy. It also unified the country.
Yeah, it did.
Well, the only way to keep going is you're going, well, what are we going to tell them today? Well, nothing's happening today. It's like string theory. Well, nothing's happened in the last 50 years, so what are you going to tell them?
Yeah, exactly. Good point.
So when we come out with the truth stagnates progress because it's a very slow progress to advance, and we're still working with liquid-fueled rockets. They're just not going to work. They're not going to get us anywhere of any distance. They get us to low Earth orbit with a whole lot of muss and fuss. And they're still as unreliable because they blow up all the time.
They do.
But so it's boring. So NASA has to keep it interesting. Well, we're not going to the moon anymore. Musk says, well, now we're going to Mars. Well, that's to spark an interest. Well, now you actually have to get there. But is that going to be any more exciting than what they created, the moon landing, and there's Neil, and then, let's watch reruns of I Love Lucy by Apollo 12, because you got there, because our movie industry does that. And the entire Star Trek series turned into a monster. But they're able to create fantasies to excite people because they could go to the next thing. They could go through a time warp. They could do whatever. They can beam down onto a planet and it's unknown. That's all movie fantasy. That's why you would want to watch it. But it's kind of boring to have Musk fire off a rocket like the last couple of weeks when he launched 3 more for Starlink. Yeah, he had 3 launches. But that's boring. They're doing the same thing over and over again. But what are they doing in the control room? Everybody's jumping up and yelling and screaming. What the hell for?
Because the thing worked, at least.
Like, you go to Heathrow and clap every time a plane lands?
Yeah.
No. Well, you see, that's the boring part. The truth is boring. And unfortunately, if we're going for the truth, we have a small audience. I'll tell you something the other night. I had that Stellarium program on my phone. So I'm up and I'm just pointing it up, and I was trying to pick out a star in the west to see what it was, whether it was Venus or whatever the hell it was that was out there. And I was picking it up like that, and this red ball came over, maybe a couple thousand feet in the air, just a meteor.
Right.
But it wasn't that. I started to think about it. I'm going, I've seen meteors before. I've seen them really low meteors, ones that are causing, like in the daytime, just black smoke coming off them and everything else. It was red and it was square and it wasn't moving that fast. It took like 3-4 seconds to cross the sky. Musk Starlink satellites are about the size of a bus. I'm sitting there going, well, that thing's up, 2,000 to 3,000 feet and it's traveling at that speed and it's glowing red and it's square. I said, that's one of his Starlinks coming down. It couldn't be timed any more perfect because I was holding the phone up like this, looking at the thing, and it just appeared. How often would you just be looking up for that 2 seconds when it's going by? But I just happened to have the phone there when it went by. Didn't make a noise, didn't leave a trail of smoke like it was nighttime, but if they're that close, you can hear them.
Yeah, you can.
And if they're traveling fast enough to break the sound barrier, this thing obviously wasn't. The one I saw before that was really big, I just kind of calculated in my head where it was going to hit the ground, and I figured it was going to hit close to Ottawa. And it landed within 50, 60 miles of Ottawa with no population, like, just wilderness, whatever. And they found it and dug it up because a lot of people saw the thing. Well, the way I figured this one going, the speed it was going, I don't think it would have made maybe 50 miles past where I was looking at. But it was low enough and slow enough, it wasn't going to burn up whatever was there. It was just a bright orangey red, but it was square.
So what was it?
I don't know. I just saw it the other night. There was nothing on the news about it or anything else. But what else is up there that's like that? Well, Starlink. And the last time I had the phone out there, I was looking at a Starlink chain, and there was only 2 of them in the chain. And the phone will pick it up and it'll show you. It'll give you the serial numbers on each one of them. He put either 20 or 21 up on each one of those launches, so he's put another 60 up there. But that's what I was out looking for. I wanted to see the chain if I could find one. You can scan all over the place with the phone. You can even do it in the daytime, which is an interesting little program. If the program isn't updated, of course, it's not going to read it. It's got to be able to read the stuff. But I was just sitting there thinking, gee, this is why when we're speaking the truth is the reality of the fact that things are not happening as fast as we'd like. It's like an entire generation has gone by. And what, they just did a spacewalk? Really? Didn't they do that back in the 60s? Like 60 years ago, weren't they doing spacewalks?
Yeah, Gemini did it.
Yeah.
Ed White, I think he was the first one out.
Yeah. And so where is the progress? Well, there really isn't any. That's the reality. But they try to make it a big deal. Every time you see a launch of any kind, they're jumping up, applauding, they're throwing papers around like it's a big freaking deal. Well, it's not. After 60 years, the technology that they claim that they have should have advanced that they could just be going up and down to low Earth orbit. It wouldn't be just a space station up there. It'd be a hotel. You come up and visit it. If it's that easy, they keep saying it's that easy. And now they're claiming, oh, the radiation is safe for everything.
Yeah.
Well, I looked at those documents. You sent that link there. Yeah. So I went down, I'm going through and oh, this is Orion, eh? Okay, fine. Oh, here, 6 days in. Weren't they just approaching the moon at that time? Then we have 3 major solar flares. So I'm looking at the radiation numbers and it's just a dead line. Where are those solar flares? Well, they're not there.
Yeah.
You go back and you look at that document that they put up. They don't give you a reading on the radiation outside the craft. Not happening. They don't show you what the actual calibration of the radiation detectors are.
No, they don't.
Like I've seen other ones where they just break the radiation down into 5 levels of intensity. And then they show that they only set the radiation detector up for the first 3 levels. They're not going to read the last 2. The most intense, they're not going to read them. They're not going to read gamma or anything else. So there's the design of the radiation detector. You need to know what it's reading.
Yeah, you've got to know what frequencies or resonances to.
And then you read the thing, and why the hell they got it in a water-filled chamber?
Yeah.
Okay? Well, that's in the link you sent.
Yeah, it was. Yeah.
And then, what is the calculation for the absorbed radiation on those 2 dummies that are in there?
Yeah, we haven't seen those. You mean Helga and Zohar? Those 2?
Yeah, but the graph that they show for the radiation is absorbed radiation. Well, if these little buggers are absorbing radiation, how come the moon doesn't?
Well, the moon absorbs radiation. We just don't hear about it.
Well, where did these moon rocks that they brought back fully irradiated?
Of course they were.
Yeah, but they don't have any. NASA's claiming that the moon rocks have the same radioactive signature as Earth.
But it can't have. Earth is protected.
If they are correct, then that means that the Van Allen belts do 0. Then every object rotating around a sun could have life. They make these statements out there. We know that the lunar surface is taking a direct impact from every solar flare, and the basic sunlight are absorbing that all the time. We know that radiation takes, like, half-life is at least 1,000 years.
It should still be there.
So when they have Helga and Zola out there for 25 days, they shouldn't receive any radiation because most of the time they're protected. they're inside their shielding. But we don't know how well that shielding works, do we?
And what happens when they get to the moon and step out inside all this radiation?
What happened to Orion when they brought it back? When it landed in the ocean, did it wash off? Because these guys weren't even wearing gloves. Nothing. No protective equipment when they were loading that on board or transporting it. Shouldn't that vehicle be irradiated? It went through the belts twice.
And it stayed out way beyond the belts, which is full of radiation.
25 days out there. I mean, where's that radiation coming from? From space. And it's just being pushed around. It does build up a little higher, being pushed around the Earth. But there's still a hell of a lot more radiation in space than they want to admit to. So they don't give you the radiation that's actually physically outside the craft. They don't give you what the hull of the ship would absorb. And of course, once it's absorbed, once the outside of the craft is irradiated, it's going to start just penetrating through to the inside where you're going to be traveling if you're going to Mars or whatever. Even if you take it away from radiation, whatever's inside is going to keep, because you're completely surrounded if you're inside the craft with radiation all around you. They don't give you that. It's not part of the story that they want to tell.
And of course, don't forget that back in the days of Apollo, the NASA press office was a major part of their operation. They had to build up the excitement for what was going on. Whether it was going on or not is irrelevant, but they had to build the excitement up, which is what they did. The astronauts were these frontier men going to a new area. They were fulfilling the dead president's challenge. So it was all built up as this huge adventure. Because it was the first time, allegedly, that anybody had landed on the moon, allegedly, they could build it up to be a big adventure. Now it's not. I mean, how many people can name the 4 astronauts who are supposed to be flying on Artemis II, which has been delayed for a year or so? We can find out who they are, but they're not on the front page of magazines like Armstrong, Aldrin, and Collins were back in '69.
That was an amazing propaganda machine they had running there.
Brilliant.
These guys didn't do anything. They were just selected, and they were internationally famous. They were household names around the world. There wasn't a movie star in Hollywood that had that kind of signature.
Yeah, that's the whole point. The NASA publicity machine, the NASA press office, was building them up, like the old Hollywood studios did for film stars. They'd build them up so that people would take an interest in them.
And all they had to do is put a suit on, helmet in the hand, and wave.
Yeah, that's right. Wave. I'm a famous person. Wave. You know. But nowadays, as you say, it's boring. There's nothing happening. People try to make it interesting. There's some good people reporting on the space program. The angry astronaut, he's pretty good.
But like I said, we're reporting the truth and it's boring. These guys are trying to make it exciting, and there's nothing happening.
No, there isn't.
They can't even build a spacesuit.
Oh, talking of spacesuits, you know that recent film we put out about Collins spacesuits withdrawing their contract? They appear to be associated with ILC Dover, who built the original Apollo spacesuits, International Latex Corporation.
Yeah.
It's on one of the sheets. I just spotted it, and I thought, hang on, either Collins are part of ILC Dover, who built the Apollo spacesuits and have now withdrawn because they can't make it work, or they're taking information from them, trying to incorporate it into these new spacesuits, which they've now stopped making because they're being examined too closely.
I think that it all has to do with the funding. The Latex Corporation got funding, got advertising, got everything for the Apollo missions. And I think they picked up the phone and said, hey, are you not going to include us? We want some of that funding. Just like Fisher Space Pen and all the other ones that sponsor them, right? Why the hell did they need them? Musk went to see Joe Fernandez, Hollywood costume designer. He went into the costume room, grabbed some of the old stuff from Spaceballs, took the plastic armor off of that, went and got James Bond, Jenny Flex's boots on, her riding boots for the thing for that movie. And he said, there we go. And he came out and said, those are the in-flight suits only. If you realize he first announced them, in-flight suits only. Well, that's the same damn suit that they just did an EVA with. And if those damn things work, then we can just get Joe to just manufacture those. We don't need to spend $3.5 billion designing a better spacesuit, because Hollywood costume maker did a better job.
Yeah. But if they had the spacesuits 50 odd years ago, 55 years ago, that worked, we're told, why don't they just drag them out of the museums and copy them?
But that's old technology. See, they don't want to incorporate old technology. That's their excuse. Well, if that's the only stuff that works, if that rocket worked, if that capsule worked, if the lander worked and the spacesuits worked in 1960s, and they can't do it today, then the 1960s stuff is the latest and greatest technology out there.
Well, we're told it worked. Where's the evidence that it actually did work?
Well, they had better zippers back then.
Oh. Why do they use zippers in a space?
You don't even do that. You don't even have to do them all the way to the top. They just work.
Oh, of course they did. Yeah, well, we're told they worked. That's the whole point of the press office. They can tell us everything. Oh, the spacesuits worked, the rockets worked, the landers worked. All right, you can tell us they worked. Where's the evidence? It's interesting that nobody has actually come back and said, you're wrong about the photographs, and this is why they are correct. Nobody's ever done that.
We'll just tell them to go ahead and test it. And then they say, that was a special film. Well, guess what? We got that 589 pages of documentation with every imaginable type of polymer, plastic, polyamide, you name it, Kapton out there, and all of it fails. So what did you make it out of?
So where's the special film that you keep talking about?
And that was up till 2008 with the latest and greatest technology. That's why I showed that document, because it shows every material that they could possibly get their hands on, anything that they could create well after the Apollo missions. They're still trying to create something that is survivable in space. That bloody force, and people have to understand that it's a force. It has nothing to do with it. You cannot take PSI and use it as a percentage. That has nothing to do with the force. The force can be measured by a mechanical device. That's what the first gauges were, mechanical devices, just like a bathroom scale. You step on them and it goes there. You step on a bathroom scale, it doesn't tell you the percentage that you are, right? Yeah. It tells you how much you weigh by force. They sit there and deny that the force is there, and yet look what's happening to the materials in that document. It's making atomic oxygen push through solid materials, damaging the material on its way.
Yeah, it does. It does.
And it doesn't matter whether it's plastic or metal or glass or anything else. It's coming out of there. And what people have to understand in space is that you have molecules, and they like to be evenly spaced throughout. You put them in a specified amount of space, and you put so many molecules in there, and they evenly space themselves out throughout whatever container you have them in. And if you jam more in there, they're just closer together. And if you remove a bunch, they're still all evenly spaced. When they get so far spaced out, they try to grab other molecules.
Yeah.
From the man-made materials, from the spacecraft. So you put a craft out there, and you're in space, and there's not enough of them, and it's going to try and grab material, the molecules from your craft, and put them in and try and spread them around evenly all over the place. That's what off-gassing is.
Yeah, it's what cold welding.
And then, when you reduce the temperature, they like to get closer together. And there isn't enough of them. You just shrink something down. You can take any physics example, put the candle and the egg on top of the bottle, right, and it sucks it in as it cools down. It's literally pulling it in. Those molecules, like when you heat them up, they expand out. That's their desired space. And if they need more space, they're creating pressure on the container. And when you cool it down, they like to be closer together. And there are charts out there to show you what the percentage that they will shrink down, like different materials, how much that they shrink, how much closer that they get together. They're going, well, we got to even things out. Well, let's grab the sides and yank it in too. Like you see many demonstrations where they heat something up, it creates pressure, and they like throw some water on it and it just collapses the thing. That's how fast it's happening. That's how fast the temperature change will change whether those molecules want to be farther apart or closer together. How much force is that for them to get closer together? That's where the force is coming from. That's the force that's pulling the atomic oxygen out of materials.
That's why vacuum is basically a negative force.
That's right. It's pulling it in. Those molecules want to be in that much space. And that has nothing to do with these guys. They always go, well, it's percentage of PSI. And nothing to do with that. Because you don't need to change the percentage, but you change the temperature. Because those molecules are going to decide how much space they need. That's where the force is coming from.